Pop quiz, hotshot. You've got 48 milliseconds of work to do, but only 16 milliseconds per frame to get it done. What do you do? My name is Colt McCandless, and while threading on Android can help cure your performance woes, it can also end up creating some huge problems if you don't understand how it's all working under the hood. So let's take a few minutes and make sure we're all on the same page. See, a thread by default does three things. It starts, it does some works, and as soon as that work is done, it terminates. Now, by itself, that's not too useful. Instead, what you want is a thread that sticks around for a while so you can feed it packets of work to operate on. But to do that, you need a little more scaffolding. First, since threads die when they run out of work, you need to have some sort of loop running on the thread to keep it alive. Just make sure to put it in an exit condition so you can terminate that loop later. In addition, you'll need some sort of queue that the loop can pull blocks of work from to execute on. And of course, you'll need some other thread that creates work packets and pushes them into the queue for execution. Now, if you've ever tried to write this setup yourself, you know it gets a little gnarly to get all of that machinery working correctly. Thankfully though, Android has a set of classes to do all that for you. For example, the looper class will keep the thread alive and pop work off a queue to execute on. And rather than always inserting work at the end of that queue, the handler class gives you the control to push work at the head, the tail, or set a time-based delay that'll keep some work from being processed until that time has passed. And don't forget that units of work in Android are explicitly defined as intents or runnables or messages, depending on who's issuing them and who's consuming them. And then the combination of all these things together is called a handler thread, which lets this look like this. Pretty nifty, huh? So let's look at how you can use this in your application. When the user launches your app, Android creates its own Linux process. Alongside with this, the system creates a thread of execution for your application called the main thread, which at its core is just a handler thread. This main thread handles processing of events from all over your app. For example, callbacks associated with lifecycle information, or callbacks from input events, or even events that are coming from other applications. And most important is that these callbacks can trigger other work that runs on the thread too, like making a change to the UI will create work packets that allow the UI to be redrawn. Basically, this means that any block of code your app wants to run has to be pushed into a work queue and then serviced on the main thread. The takeaway here is that with so much work happening on the main thread, it makes a lot of sense to offload longer work to other threads as to not disturb the UI system from its rendering duties. And this is how the entirety of Android's threading model works. Now, lots of packages of work being passed around between threads and worked on as needed. So, with all this in mind, some of Android's threading classes make a little bit more sense. See, each threaded class is intended for a specific type of threading work, so picking the right one for your needs is really important. For example, the async task class is ideal for helping you get work on and off the UI thread in the right way. Handler threads are great when you need a dedicated thread for callbacks to land on, and thread pools work best when you can break your work up into really small packets and then toss them to a bunch of waiting threads. And intent services are really ideal for background tasks or when you need to get intent work off the UI thread. And like everything else, there's not a silver bullet here, but knowing which primitive is best for what situation can save you a lot of headaches. Now, if you ever want more insight into how your app is leveraging threading, make sure you spend some time getting comfortable with Systrace. It's a fancy tool that'll school you on how that mumbo jumbo is working underneath the hood. And if you're looking to get schooled more, make sure you check out the rest of Android Performance Patterns videos. And don't forget to join our Google+ community for more tips and tricks on threading. So keep calm, profile your code, and always remember, perf matters.